Hi everyone, my name is Lisa Tonner, and I'm going to be talking about type 1 diabetes. Type 1 diabetes mostly affects children, adolescents, or young adults, but some latent forms can occur later in life. The disease is characterized by an absolute deficiency of insulin due to destruction of the B cells in the pancreas. And without these B cells, the pancreas fails to respond to glucose, creating symptoms of insulin deficiency, such as polydipsia, polyphagia, and polyuria. The pathology of type 1 diabetes is very complex. It involves tightly controlled microenvironments, several highly specific immune cells interactions, and eventual breaking down of immune tolerance, leading to beta cell death. Type 1 diabetes is an autoimmune disease characterized by the destruction of the pancreatic beta cells by islet reactive T lymphocytes, leading to the inability for the pancreas to produce insulin. There are at least 57 independent genomic regions defined by 104 single nucleotide polymorphisms that confer the risk for the development of type 1 diabetes in humans, making it a very complex scenario from which to try to predict predisposition to autoimmunity. The human leukocyte antigen gene complex, or HLA class II, on chromosome 6p21 has been identified as a genetic factor with the strongest association in certain patient populations, with 90% of Caucasians expressing the HLA DR3 and are the DR4 alleles. While most genes have been identified as risk factors that are present mainly in immune tissues, others have been found in endothelial and pancreatic tissues that regulate various pathways. To make it even more complex, there are a host of type 1 diabetes candidate genes that also control cell signaling pathways that have a significant amount of reactions as well. The clinical onset of type 1 diabetes occurs when the majority of beta cell mass has been destroyed and the cells that remain have lost the ability to produce insulin to maintain adequate glucose control. The best window of opportunity for treatment to prevent the onset of type 1 diabetes has more than likely already passed before a patient presents any signs or symptoms, creating a significant challenge to identify those who are at risk. Currently, there is no therapy that can stop or reverse the progression of this disease. The current standard of care for a patient with type 1 diabetes is the administration of human recombinant insulin. Islet transplantation has also been explored as a treatment option to replace lost beta cells in the pancreas. However, in order for this to become a viable treatment, it must overcome a series of major limitations, which include a low donor islet availability, poor long-term graft survival, as well as the reoccurrence of autoimmunity. There are different types of insulin for type 1 diabetes. The first one I'm going to talk about is rapid-acting insulin, such as Lispro. It begins to work typically around 15 to 30 minutes after sub-Q injection and peaks in 30 to 90 minutes and continues to work for 3 to 5 hours. Rapid-acting insulin covers insulin needs for meals eaten at the same time as the injection. This type is often used in conjunction with longer-acting insulin. Long-acting insulins, such as Glargine, begins to work 1 to 1.5 hours after sub-Q injection, with no peak time because insulin is delivered at a steady level and continues to work for up to 24 hours. Long-acting insulin covers insulin needs for about a day. Insulin can be very expensive. It can run from $90 to over $1,000 per vial, and the prices have nearly tripled and continue to increase. In certain cases, an insulin pump may be needed. Insulin pumps are small computerized devices that mimic the way the human pancreas works by delivering small doses of short-acting insulin continuously or at a basal rate and is also used to deliver variable amounts of insulin when a meal is eaten via a bolus. Out of pocket, an insulin pump can cost around $6,000, plus another $3,000 to $6,000 a year for ongoing supplies, making it not cheap. In conclusion, there are numerous regions on genes and cell signaling pathways that can show the risk for developing type 1 diabetes, but it is a complex task to try to predetermine this condition. Because there is currently no therapy available to stop or reverse the progression of the disease, research and development is ongoing. And currently, the only way for treatment is through insulin. Thank you.